Brilliant, thank you. Right, everyone, so welcome to Every Event, Everywhere, All at Once. Some of you might recognise this, and there are a few nods to the film with the same name, so you can see if you can spot them. But when it comes to events, we tend to end up with an awful lot of terminology, and it's all very much discombobulating, which means it's confusing and it makes you feel a bit anxious. And so the whole point of this talk is for it to be a disambiguation. I want you to understand what these things mean and be happy about using them and when people talk to you about them. So, you had a brief introduction to me, but I am the author of a book, Communication Patterns, and I'm also a principal architect, and I go into companies and help them to own their architecture, including things like event-driven architecture, which we're going to have a look at today. Now, this was going to be a sort of A to Z of events, but the problem with that is that actually most of them begin with E. So I thought, what can I do instead? And so came up with this every event from everywhere all at once. And the other thing with A to Z is that it doesn't really introduce things in an order that you can then build on prior knowledge. So we're not going to do these in alphabetical order. So this is what we're going to have a look at today. We're going to look at things at a high level so that you've got a general understanding of all these things. So, really good place to start here is, what is an event? And you may think, oh yeah, that's obvious. But there's actually even more than one definition when you look at a dictionary. And so if we look at this one, an occurrence, something that happened, it's kind of quite vague, isn't it? It's like, okay, something happened at some point, we're not really going to tell you when. And so that doesn't help us that much. But if we look at this definition here, a prearranged social activity. This is the kind of event that we interact with on a daily basis, because this is actually a calendar event. And this kind of event can really kind of be confused a lot with computer events. And so I want to show you the difference between them. And so with these calendar events, maybe it's a party, well, hopefully it's a party. Maybe it's a doctor's appointment, hopefully not. Maybe it's a flight or some other travel, but it's all to do with date and time. And calendar events can be in the past, they can be in the future, they can be happening now. So like this talk and DDD Europe. That's happening now, and this is the big difference between the computer event and a calendar event. So let's look a bit further into this. This definition is actually the closest. So we've got an end result, an outcome. And now I'm going to give you a nice umbrella term to use for a computer event. And this is something that has happened. Now that's a very important bit, and I'm going to talk about this a bit more. But you might be thinking, okay, that's really high level, but actually it needs to be, because there are lots of types of events and lots of ways that they can be consumed in computing. And we're going to look at lots of those today. Now, events aren't a new thing. You may have heard of them because of the rise of kind of distributed computing and event-driven architecture, but they've been around a lot. Don't worry, you don't need to read this. But if we look back here at this example from Java, we have an event object. And this was actually introduced in JDK 1.1. And that came out in 1997. Winamp came out in 1997. And I bet there are some people in this room who were in school in 1997. So, events, not new. But we can have a quick look at the difference between events from now and events from, I'll call it yesteryear. It wasn't that long ago, really, was it? But a lot of these subclasses here are involved with the UI, and there's some that are to do with changes. Now, if we have a look at one here, one of the biggest differences here is that this name is in the present tense. And I've said that it's something that's happened. So events now would be changed rather than change in this case. And also, this event is actually 3 different events in one. Something could be added or removed or changed. And so normally we would be splitting that up into 3 different events these days, unless they're all within an aggregate, but I'm not going to go into aggregates today. You've already had a really nice deep dive into that, and I do not have time. I have lots of events to get through. So, moving on here, we can see that there's the state inside this event. So this event is basically a wrapper for something that has changed. And so we've got a key here, which gives us an identity for the preference that's changed in this case, and also its new value. And then the other thing you can see is some validation. And this is quite interesting because this is why I was saying it's actually 3 different events. And this is a form of coupling because all of the consumers at this event have to implement this logic to work out which of these 3 events has happened. If that's null value, it means it's been removed. So this is a form of coupling. If that changes in some way, everything that consumes this also has to change. So that was a quick look at where events have come from. Now I want to have a quick look at events versus commands, because it's important to see the difference between these 2. So commands and events are both types of message. And messages are just basically getting information from one place to another. So let's have a look at the difference between these 2. So a command is an intention. You want something to do something for you, and it gets sent. And sometimes often it's to one recipient, but sometimes it's to more. And when we have these extra recipients, we also end up with this extra transaction boundary. And that's when we're going to have to think about whether we need to do a retry or a rollback and keep everything in sync. So the commands are sent. We expect something to be done. We can't guarantee something will be done because it might all go wrong. It might decide, no, I'm not going to do that. So that's the command. And an example of that would be change preference in the present tense. Then we've got events. And so we've got an event producer that produces a fact, an event which has happened in the past, and it publishes that. It doesn't care what people then do with that information. It just goes, this has happened, do what you want. I'm not expecting you to do anything. And so with these events, they can also have different transaction boundaries, and I'm going to talk about that towards the end because that's a much more complex thing to think about. And then there's an example for you. So preference changed, it's in the past. And now Oscar did a very good blog post about the difference between the command and the event. And here he used this in that blog post, and so I wanted to share it with you. So we've got the command intent, and then we've got the event result. Now, one way to think of this is actually thinking of it as fact, because it's immutable. We can't change what has happened. But this is a good way to remember the difference. I hope it helps. Now, we can actually look at the difference a little bit more if we think about a work item within like a task management system. So if we have the command to create that work item, we get a state of to do, we get an event of created, because it's in the past, and messages can be lots of different things. So here I've just got, I like creating work items. Don't like completing them, but I like creating them. Then if we start a work item, it changes to being in progress, and it was started. Then if we complete that work item, it's now done, and it also was completed. So that's a good way to think about that. Now, I did say that these were types of messages, and I'm going to emphasize that again. These are all ways of getting information from one place to another. Message is kind of like the parent object, if you're thinking about this in programming terms. Now, on to the next one, event listeners and event handlers. These are terms that are often kind of used interchangeably. Now, we can break them down semantically to understand them a bit better. So first of all, we've got a listener, and a listener listens. Somebody actually named something appropriately. But we can also call it a subscriber. And what it is doing is it going, I'm looking for a particular event. Maybe that is preference changed. And when that event happens, it then triggers what's normally called a callback function. Sometimes this callback function is the bit that is also called a handler. So there's a little bit of confusion in there. But that callback function happens asynchronously after it's been triggered, and that is the reaction to the event. And then together, these are normally known as the event handler. So there you have your event listener, event handler. Sometimes the whole thing, people call it an event listener as well. But it's pretty much the same thing, but somebody might be referring to one of these bits inside it instead. So it's good to know all the different things that people might call this. Right, moving on, I've got lots of these to go through. So, event streaming. Now, event streaming acts on continuous flows of data. It's reacting in near real time as possible when changes happen. And so event streaming is normally in the kind of analytical area. It's where instead of using some sort of batch process, we now want to move to be able to analyze things in real time and react to them. And to do this, you need an event streaming platform. Various options out there. I will talk about at least one of them today. We also need event streaming APIs in order to get this data in. But what we do is we have producers which produce these events. And there's a few examples here. Microservices might be sending events in IoT devices, a few different ones there. And then the platform needs to then store and pass on these events to its consumers, the consumers that have subscribed to those events. And so these might be things like a data warehouse, things like OpenSearch, and other different things that you want to connect. Now, the way it does this is it uses a thing called a message log. Now, message logs can be used in other ways as well, but this is what the streaming platforms do. Now, what better way to talk about logs than to go to Star Trek, because they're always making captain's logs or first officer's logs or whatever. So, we've got a few high-level logs here, and our producer puts these into the message log. These are events in our message log. And what they have is this thing called an offset, which you can kind of think of as a bit like a position. But we have consumers, and what they do is they consume these events based on the offset. And what they do is that they commit that offset either every X messages or every Y seconds. And so they're reading through this. Some of them, they may want to read through a whole stream. Others may want to get a window of 10 or 100 to do some sort of analysis on it. Now, what happens when we have a problem? Maybe they kind of encounter Q, who knows? But it may mean that that consumer needs to come back, and that offset that they last committed might not have been the last thing that they really processed in its own code. And in that case, it may need to start earlier again. And so you need to be thinking about idempotency when you are consuming these logs, because you might end up processing something more than once. And you don't want that to have a different effect the second time you process it. We also have message queues. Now, these aren't used in the streaming, but I want to show you the difference between queues and logs, because a lot of the products these days actually support both of these, and they've kind of merged together a little bit. And so it's important to understand the differences between them. So we've done the log, which was the streaming. Now we've got a queue. And here we've got a producer, which is putting things onto the queue, not that type of queue. And we have consumers, which are reading things off the queue. Now, with the message logs, those items within the log were not taken off when they were consumed. They do have a lifetime, and so they can be taken off at some point, but just because they're consumed by something doesn't mean they're taken off. With the message queue, as long as something is consumed successfully, it will be taken off the queue. Now, we can have more than one consumer. We've got 2 on this one. It's called a competing consumer pattern, for anyone interested in that. But if one of these consumers tries to consume something and doesn't say, I've done this successfully, then that item will end up back in the queue, available again to be consumed. So they kind of need to say, yes, I've consumed that, everything's fine. And so this now leads us on to event-driven architecture, or EDA. So we've looked at a few different ways that you can actually implement an event-driven architecture now. But when we talked about commands earlier, if you've got a distributed architecture which is implemented using commands, that looks very different from a distributed architecture implemented with EDA. So let's have a look at that. Here we've got a distributed architecture, and when we are using the commands, like I said earlier, we are addressing a specific service, saying, do this. It's an intent, okay? And so we can get some very confusing diagrams like this. Now, the upside is we do know who we're talking to. So that's a piece of information we do know. But you can end up with coupling, and you can end up with high complexity, because this is simplified. What happens if you've got hundreds of services or thousands using this kind of model? And so this is the using the commands. Now, if we look at an architecture that is similar but uses EDA, we can implement this using some kind of broker, and all these services can publish and subscribe. Now, we could look at this and go, oh, that's a bit of a bottleneck, and there are a few ways of sorting that out, things like having more than one instance of it, but too much information for today. But one of the big things here is that, yes, this is much nicer diagram, isn't it? But it doesn't actually tell us who uses that information. If we wanted to know who uses the information from service A, we would have to go and have a look in the broker and see who is using that. So interestingly, diagrams like this stop communicating the information about the interactions in our architecture when we start publishing and subscribing to events instead. And when you're dealing with any kind of distributed architecture, what you're really dealing with is what I call a wall of ivy. Now, if you think of all the strands as the data flows, it's very hard to pick those out, isn't it? Especially the further away you get. And so you don't really know who's using the information from your event. You certainly don't know who downstream of that service is using your information. And so this is where we really need to be thinking about our knowledge management. So really, really, really carefully think about your knowledge management if you are working with distributed systems, especially. But any kind of system needs good knowledge management. Right, on to the next one, event storming. This is the one with the sticky notes. And I'm sure Alberto is going to talk to you more about this a bit later. But But I'm going to give you a high-level overview of this, and so you know what it is and why you would want to use it. Now, you will most likely come into contact with big picture event storming. And so I'm going to have a look at the sticky notes and the legend of the things that are used specifically for this level. Now, the orange sticky notes are events, and you now know what events are. So I don't need to say any more about that. The green ones are opportunities. Maybe this is taking advantage of something, or we're looking at things that you think, oh, actually, we could improve that. So those are our opportunities. We have these kind of bright pink ones, which are hotspots, and these are where we think there's a problem, or people don't agree over something, or we just think this really needs attention. And to kind of bring slightly more attention to those, they are generally twisted 45 degrees. So they're a bit more in your face, we need to sort this out. We then have these small yellow ones, which represent actors, and we get these little blue ones with arrows, and they're used to vote on what people think needs attention. Because this is collaborative, we're going to be using some voting. And it's quite good practice to get people to put their initials on that, because when you're discussing it afterwards, it's kind of useful to then get why did you vote for this, kind of thing. So that's the votes. And then these big pink ones, these are systems which we are interacting with. And so big picture event storming, you will probably get something that's much bigger than this, much longer. But what you're doing is you're bringing together all of the business and technical stakeholders, the people who have that information in their heads, and you're getting them to map out these event flows collaboratively. And this means that you get that implicit information out of people's heads, and you break down these silos between groups. And you'll probably get lots of people going, oh, I didn't realize that's how that worked. And it's really good for getting all that information out of people's heads. So a quick example. If we zoom into here, we can go back to a little bit more Star Trek. So our ship has docked with the space station, resupply then started, and the resupply finished. And this is all to do with that space station stores system. And then someone has said, oh, do we really need to be thinking about these separate stock types when we're in here? So a very quick example there of the kind of thing that might come out of these. But this brings us really nicely onto pivotal events. Now these are kind of the more important events and end up being your candidates for the system boundaries. And they're normally marked with this yellow line or yellow tape once you've identified them. But you'll get these throughout your big picture event storming. And these are kind of the places where you've got lots of interested parties. They're normally where the rules of the game change. If maybe you've got some kind of order system, there might be an event where you actually ship the order. So it might be order shipped. And at that point, the rules probably change. You probably can't change that order in the same way as you could before it was shipped. So that's the kind of thing that becomes a pivotal event. And you end up with lots of conflicting terminology at these points, because normally it's where we get different bounded contexts which you can help, this event storming helps identify. And so you get these different models, these different conflicting names and language. And because of that, with these pivotal events, you're probably going to end up with some kind of model which helps translate from the model of one bounded context into the other. And so you're going to get these different models at these pivotal events. Now, event sourcing comes in 3 delicious flavors. Chocolate? No. Big picture is the first one. That's what we've just talked about. And this one is the more discovery-oriented. So we're getting people in the room, we're going, okay, tell us what you know. And this is going to be for business and tech people. We've then got one called process modeling. And this is a sort of lower level. This is more design-oriented. And we get a smaller, more focused group looking at actually modeling processes at a lower level. Then we have one called software design. And this can be either technology design-oriented or user experience, user interface design-oriented. And this would be a smaller group focused either on that technology or the user experience. So there you go, a nice introduction to event storming. You now know what that one is. Now, up until now, we have been talking about communication, moving information from one place to another with these events. Event sourcing is another form of communication, but this is about storing the events. So when we're not using event sourcing, we're using something that's normally called stateful storage. And this might be a relational database, it might be a document database. But when we're changing this information, it's being overwritten. We're losing that original information. And so what we have here, when we look at it, is just the current state, whether we have a last updated date or star date, as it is here, or not. If you need to recreate the data at one point, if you don't have a backup or some kind of log in the database that tells you what happened at that point, you can't recreate that data. And you probably can't recreate that really annoying bug, which only happens on the second Tuesday when the moon is full. You know the ones. But when we are looking at sourced entities, we are recording every change in state of an aggregate or an entity. And so what we get with that is we get this history of state, and you can think of it as versioning. Now, this is just like putting code into a repository. We can read through all these changes of state, reapply them to get whatever state was at a particular point in time. So this is a bit like time travel. We get enough of that in Star Trek, I think. Right, event sourcing streams. I already talked about event streaming. Now this is one of those terms that's a bit overloaded, a bit like aggregate, entity. They all mean different things, don't they? So streams in event sourcing, these are when we have this collection up here, as you can see up here, and these are all those state changes to do with one particular aggregate or entity. And that means that you're going to get lots of these different streams. Now, it is best practice normally to limit the length of your streams because it can cause sort of issues with the amount of time it takes to reapply things. And so normally what you would do is you would use some kind of business or process timescale to split them up. So maybe you do an end of day, an end of shift, an end of process, and at that point you then start a new stream. So you only need to deal with however much you need. So that's streams. We've written. Now we need to read from our event sourcing. And so, as I said, all we need to do is go through each of those state changes, apply them each time, and we get the current state, or whichever state, whatever point of time we want. And we can do this by getting that information kind of directly from our event store. And one of the ways of doing that is through read models or projections, which a lot of these event stores will create for us. So this one's a quick one. I've just used this phrase, event store. Now, this definitely needs a disambiguation. So this is the database that you use to store your event sourcing data in it. Now, you can use some kind of generic data store, maybe things like Postgres. And there are certain projects out there which will help you with this so you don't have to write all that code. So a couple of examples there are Martin and MessageDB. So those help us use a non-specific data store. But then there's also other data stores which are specifically for event sourcing. And one of those is called Event Store DB. So there's your disambiguation. We have a product, event store, and we have the generic term of event store for a event sourcing database. So that one, told you, short. Now, this one isn't as depressing as it sounds. A Tombstone event. Now, some of you might remember these from things such as C and C++, and they're used in that to help with memory management. When you've got a bit of a dangling pointer, you don't want it to be messing with your memory. And so one way to use tombstones is to get your pointers to be pointing to the tombstones and not messing up your memory. So that's kind of where it came from. But really, a tombstone event can be considered a marker for this data is no longer there. Nice high level that. And I'll show you a couple of examples because tombstone events don't mean the same thing in each context. Again, sorry. People have taken this and used it to mean different things. So with event sourcing, tombstones are normally used to indicate the end of a stream's lifetime. And if you're creating a read model or a projection from that stream, it can signal, please delete that read model. So Event Store DB uses a tombstone to indicate that this stream actually needs to be removed. Thank you very much. Goodbye. With Martin, that uses it in a different way. So if we get a failure, a transaction, it will try to insert a tombstone. And the reason it does this is because it's trying to stop there being any kind of gap in that universal identity that it uses, because it can muck about with when it's creating these projections and read models for you. So we can say rest in peace, failed transaction. And so that's two different things there, but really they are both saying this data is no longer there. Now that was event sourcing. Event streaming, Kafka can also use these for error handling again. Now, this is a particular pattern which is used for maintaining the order of events when one event can't be processed. But because all these events are to do with one specific thing, we don't want them to get out of order. And so what happens here is that main app will push it onto a retry, and it's wanting that Kafka retry app to have another go. But then it comes up with another event, which is to do with the same thing. And it goes, oh, I know that I've put an event onto the retry topic here, so I'm going to put this one on as well. And what it's doing is it is storing it in there. And so it will keep pushing them onto the retry until these tombstones get put out by the retry. And these tombstones actually signify success. That makes sense, doesn't it? But it's a success of the retry, and what it's saying is this data is no longer here because I've successfully retried it. And then this main app will then look for these, and then it will remove those identities from there. And so when event number 3 comes in, it doesn't need to put it onto that retry topic. And so, yeah, it doesn't make much sense, really, but it is kind of saying this data is no longer here. This is, I would say that this event here is actually more like a command, if you think about it, Because really there's kind of an expectation of, oh, stop sending these things to me because I've processed them all. So when you're using events, have a think about whether you're really trying to send commands kind of disguised as events, because this is kind of definitely edging towards that. But so there's the different examples there. Now, I've saved these ones for sort of more towards the end, because domain and integration events are one of the biggest confusions when it comes to events. And I'm actually going to give you some better terms to take away to use instead. Now, interestingly, domain event is not defined in Eric's DDD Blue Book. It was actually defined after that was published. But it is defined in this orange reference book, which you can get on Eric's website. And so he defines it as something happened that domain experts care about, a representation of something that happened in the domain. So these are part of our domain model. They're important to the business. Now, you may have heard that domain events are things that happen maybe in memory or in process, and they at least happen within a domain, or it's probably technically more a subdomain in the way you're thinking about it. It's a subdomain of your overall domain. And then, you probably heard that integration events are the things that we need to communicate between our domains. But if we think about that definition, things that are important to the business, integration events are quite often the most important things to the business. So integration events are domain events. And so here is the big confusion. These are all business facts. They are all domain events. So really what we need to be thinking of here is that events should be designed like APIs. And I'm not the only one who thinks this. Oscar and Nick kind of both agree with me here. Because the thing is, we don't have domain APIs and integration APIs. That would be confusing. But what we do have are private APIs and public APIs. And this is a much easier way to think of this. So, all of your events are business events. They're important to the business, therefore they are domain events. Some of them are going to be private events. They only apply within a subdomain or even smaller region. And then some of them are going to be these public events. Now, if they're public events, we need to be thinking about that shared model. These public events might be your pivotal events, which we talked about earlier. See, all connects up. And of course, if we make changes to these public events, we're going to need to think about versioning them. And when we have these private events, we don't necessarily want to send all the information from those private events to something else via a public event. So you might end up having multiple private events, which essentially get squashed into a public event, or bits of them get put into this public event to communicate. And that brings us nicely onto event granularity. Now, this isn't an event in itself, but we really need to think about the purpose of our events and also the data inside them. We looked at that briefly at the beginning, but we need to know how much data should we be putting in there, and what data should we be putting in there? And the answer to that, of course, is it depends. But what does it depend on? We can think of our events as being somewhere on this event granularity continuum, not the queue continuum. And so at one end, we have less data, and the other end, we have more data. Now, you may have heard of these as referred to as thin events and thick events, but those are some kind of triggering terms that we should really be moving away from. So let's think of them as less and more. We can also think of these events that have less information as more of a notification event. They're just saying, this happened. When we get to the other end, we're thinking more about context, and we're giving much more information at this end. And then when we're kind of in the middle, this is more of a status update. So it's saying that here's your changed information, or this is what's happened. And when you're sending state, what you're doing is you're employing event-carried state transfer. And the aim of this is that we are giving the information needed without that consumer having to call back to the producer for more information. So, why do we need to think about where on this continuum our events are? Because there are always trade-offs. At this end, we can get the clickbait anti-pattern, and this is one that Oscar named. And this is basically where you have an event where it's pretty useless. You can't do anything with it unless you call back to that producer and go, well, here's the registration number, what actually did happen? So, pretty useless event. And what it means is that you get more network traffic, you get a higher latency because you have to go back over the network again to get the information you need. And that producer then has to spend its resources answering all these queries again. And what happens if that producer isn't available? You can't get that data. What happens if that data changes before you then query it? You've then lost that original data. And so you may as well just put that information into the event in the first place. So that's the clickbait anti-pattern. At the other end, we can get an all the things anti-pattern. And this is where we get these big bloated, generalized events which just have all the information, including the kitchen sink, in there for anyone who wants it. And the big problem with that is that you end up with coupling here. You increase coupling because you keep having to change that event because it's got so many things in it. So every time one of those changes, you have to change it. It also increases cognitive load and maintenance of those events. And actually, this is not good for the environment because you're using more power to create these events and to store these events as well. So think about the environment as well when you're creating your events. Now, generally we are told, keep your events as small as possible, but that doesn't really communicate what it's trying to communicate. It's been condensed too much. What it really means is as small as possible and as large as necessary. So I talked about this a minute ago. Generally, you will want to be implementing event-carried state transfer. We don't want the consumer to have to call back to the producer to get more information. There will be exceptions to this. Sometimes security can be an issue, in which case you only want certain services to be able to actually get hold of that information, so you may need to take that into account. We also can consider the fact that the consumer may still need to talk to other services to do what it needs to do. But with this event-carried state transfer, the producer has done all it needs. Now, if you're giving too much information, other services can then go, oh, I can use that information to implement this and do that. And so this is going against the tell, don't ask principle, which I think is a very confusing name. Basically, it means the object or the service that has the data should be working on that data. And in this case, that is the producer. So the producer should be giving us an answer, not the information that we need to work out the answer. So that was event-carried state transfer. And now I know what you've all been thinking. You've been thinking we don't have enough different types of event. Am I right? So I thought I would give you a bonus one as well. So this one is the non-event. And I think you'll probably recognize this one. Here it is. Well, what did you expect? It's a non-event. So that was your bonus. So today we have gone through all these different types of event and event-related information here. It's been a bit of a whirlwind tour, but when I publish the slides, there will be lots of further reading on there if you are interested in that. And I can't say that I have covered all the events, because it's impossible to cover them all in one talk, possibly all in one day. And people keep inventing new ones. So what I've tried to do today is just give you the basics of the kind of most common events and event-related things that you are going to come across. So that should be useful to you. So for everyone who is keen to kind of get ahead with things like this, I do offer workshops and consultancy packages, which you can find on my website. And so I want to say thank you, and I really hope that this has caused less confusion than you already had to begin with. So thank you very much.
Thank you very much, Jacqui. So I think we have time for a question, if it's okay with you.
Yeah.
So please, if you have a question, we can throw the mic. Okay, you're just here, so I will not throw it.
I'm not going to throw it.
Sorry.
Okay, it's working this time.
Yeah.
Hi, Jacqui. Quick question around events and crossing over to business stakeholders. As a lot of businesses still use file-based transfers, they use synchronous communication, and how to convince business to actually start using events properly, other than event storming, obviously, because then they will know that they are using events, but if they're reluctant even to try.
Yeah, it's always a good one, that. It's like, how do I convince people that this is better than what they're doing? Because everyone always says, but this is the way we've always done it. Yep. And that is one of the kind of biggest stiflers of innovation, especially in places like government and bigger businesses. So when you're really trying to convince people, it's really difficult, especially if you're like an individual contributor yourself. And so, as you said, event storming, doing these collaborative things together is quite a good way of kind of introducing the idea to people. But also, the biggest thing you can do is kind of just, it's the show, don't tell. I tried to combine that into just one word there. So it's really kind of saying, look, here's this little mock-up I made, or, oh, look, this is how this business has done it. And it's kind of showing people how it can, how things can improve. But it's kind of, you've got to do it without saying, I think you're wrong, because then people are going to get defensive. So it's, this is kind of the communication skills and the kind of the social stuff that you really need to kind of think about. But yes, it's difficult.
Okay. Thank you.
Perfect, thank you. Any other questions?
Can you hear me? Yeah, okay. How can we handle the transformation of internal events in a way that they become integration events without a risk of coupling two different systems together?
Okay, so yeah, the question is about the private events. How do we make them into kind of the public events? And it's about having that shared model. You can't completely uncouple everything from each other when you're creating software. it's impossible. You need to have some kind of shared understanding. If you think about it, software has the shared understanding of zeros and ones right at the bottom of it. We can't get away from having this kind of shared understanding. And so it's making sure that we have that shared understanding. And one quite useful way to do that is having the consumer-defined contracts. And so that means that the consumer of that event is actually in control of that event. And you will use tests. You can use something like Pact to help you with that. That's an open source piece of software. And so it means that the consumer is actually in control. And you have these tests which you run. And if you break those tests, you then got to, if you really need to make that change, you've then got to go and talk to the consumer team and actually work together on it. So that's a particularly good way of doing it. It's dangerous coming to these conferences.
Yeah. Okay, so you mentioned the in a distributed system that you may not have access to know who the consumers are. I'm curious if you have any insight into solving that issue, because I've run into it a few times now.
Yeah, good point. So that's kind of partly what we've just been talking about. It's like, oh, I'm going to make a change to this event, and then something breaks somewhere in production, and you didn't know. You thought Team A and B were using that event, but actually Team Z was using it for something. And one of the ways of stopping that from being such a big problem is kind of what I was saying about that continuum. It's not giving everyone all the information they could ever need, because then they're probably going to do something with it, and then that's more likely to break. So that's one way to think about it. But then the consumer-driven contracts, just as I talked about as well, if those events are consumer-driven, then you definitely know who the consumer is. So that's definitely a good one.
Can I ask a follow-up?
Yep, go for it.
So I've run into, like, you could have people write tests for the people that are consuming, but then there are people that are consuming further down the line, right? Any thoughts on that?
Well, if the people consuming further down the line, then they're a consumer of the next service, and so they want to have the consumer-driven contract with that service. And so you can
Sure.
sort of daisy chain it. So, yeah,
Cool.
Definitely a good one, that one.
Yeah.
Actually, I have a follow-up on that. We've solved that by, or we're in the process of solving it by having a registry of all the events, the exported events, and our build pipeline will then break the build if we do something that breaks the event specification. So if we're going to do a breaking change, we have to talk to anyone consuming our events. It also gives a picture of who is actually then consuming these events, since we have that registered as well.
Yeah, that's a
a
very good
different
one.
way.
So yeah, have a kind of catalogue of all the events. And this is where it's really important to have that distinction between those private and public events, because you don't want people accessing your private events, because you don't want to be breaking things when you don't think people are going to be using that. And with brokers, you can control who accesses which events. So even your private events can go through the same broker as everything else, but you can then control who has access to that. And therefore, you know, these are my private events, I can do what I like with them. Thank you very much. Yeah, good one.
So just one final question. After this, then we will go on break.
Everyone wants a break. Ooh, one over there.
So quickly, you mentioned the shared model. Shared model is not just the events, and there is more to it, like documentation, and you only briefed on the knowledge management topic. And I would maybe phrase the question this way. Is your book the answer to the question on how to manage knowledge in large organizations? Or is there like a couple of tips and tricks on how to do it when go beyond pact and its contracts?
So knowledge management is a huge topic, which I do touch on in another talk which I've done. So if you're more interested in that, have a look on YouTube, because I've done another talk on that. But knowledge management is really kind of key to understanding your software and also to building your software. So yes, with distributed systems, you need to have various types of knowledge management in place. Maybe it's using these consumer-driven contracts, maybe it's using your catalog, but there are lots of different ways to manage knowledge. And I haven't got time to go through all of them today, but I haven't got the slides for them either. But yes, knowledge management is really key because, as you saw with that ivy, if you don't understand what's around you, then you are going to randomly break things, and you don't really want to be doing that in production. Right.
Perfect. Thank you very much. Thank you very much, Jacqui. Just a applause. Thank you.
Thank you.